Yes, it is a class on current electricity, physics, higher secondary second year, and the class. This topic is very important for class as well as entrance point of view. Minutely follow the class. Very critical things are there which will be discussed in due course of time. Minutely follow the class. First of all, what is current? So, in a very simple way, we will define. In due course of time, we will explain it in details. In very short way, the time rate of the flow of charge in a conductor is called current. Means when there is a question of current, we need a conductor, because in conductor there is free electron. So without electron, without free electron, or without electron, current is not possible. So here it is defined as the time rate. It is rate, q is the charge and t is the time. So del q is the change of charge and del t is the change of time. So, and when time tends to very close to 0, not equal to 0, then dq limit del t tends to 0, dq by dt is equal to dq by dt, that is equal to I is equal to dq by dt. When the flow is uniform, when the flow is of charge is uniform, then we will just write I is equal to q by t. So this is all about current. Current I is equal to q by t. So another things, when I is equal to q by t, if you think about the SI unit, the SI unit of current is ampere, it is known to you all, and CGS electromagnetic units, it is biot or ampere, and 1 ampere is equal to 1 by 10 biot, and it is a scalar quantity. So here another some important regarding the current is that ampere 46.25 into 10 to the power 8 electron per second through any cross sections of a conductor. Number 2.2, by convention, the direction of current is the same as the direction of positive charge or cations. Whatever the direction, if the positive charge direction is in this way, the electric field direction is also in the same as that of the direction of the motion of the positive charge, and the direction of the current is the same of the direction of positive charge or electric field applied, and the direction of the current is the same as the direction of E and direction of the positive charge movement, but it is opposite to the direction of the movement of negative charge. So negative charge is always opposite to the applied field. If field is in direction, the negative charge will move in this direction. So the direction of the current will be the opposite to the motion of the electron. So the direction of current is in this way, but direction of the electric charge is electron is towards the backward. So this is what is told in this para. Now let us assume current due to translatory motion and another is current due to rotational motion or rotatory motion. So current due to translatory motion, if the positive charge moves in this direction and comes out in this way, so in this way, if we assume the number of particles is n and each particle has charge is equal to q, if you assume each particle has charge q, then in a specific cross-sectional area of the conductor, say A, what is the current in the translatory motion? The current in translatory motion is I is equal to q by t. In 1 second, t is equal to 1. This is will be n, and charge is equal to q, and q is the total charge and the area is A. So the charge is equal to current is equal to I is equal to NQ into A. Now, if so, in this case, if you assume that the number of n particles are in a specific volume of the container or the conductor, in specific volume of the conductor, then the in specific cross-sectional area A with velocity v, then for 1 second I is equal to q by t will become q. So for total charge this will be n particle nq, and for this specific area the cross-sectional area is A and with velocity of the particle is v. So the total current I is equal to nqva or AV. Now, let us assume a unit charge cube is revolving in a circular path with radius r. So, what's happen if its velocity is v and frequency is nu, or the angular velocity is omega, or time period is equal to t. If you assume with this moving charge q, then I is equal to q by t. This is equal to q into 1 by t. 1 by t is equal to frequency, q is equal to nu. So here we can write current is equal to q by t, and we know 1 by t is equal to frequency. So q is equal to q into frequency, and frequency again is equal to 1 by time period. So nu is equal to 1 by t means q by t. Again time period is equal to twice pi r divided by velocity v. So if you do this, you will find qv by twice pi r. Again v by r, these two is equal to angular velocity omega. So q by twice pi into omega, that is v by r is equal to w. So when rotatory motion, current due to rotatory motion, we get I is equal to in due course of time will come in need with these formulas. In short, current are of two types: alternating current and direct current. Alternating currents, the magnitude and direction varies with time, and it shows only heating effect, and it's represented by this. Now, direct current, it shows heating effect, chemical effect, and magnetic effect, and it is represented in this way. So this is basic difference between alternating current and direct current. So some other important tips are there. What are the current carriers in these substances? If it is solid, the current carriers is nothing but the free electrons, and if it is liquid, current carriers are positive and negative ions, anions and cations, and if it is gas, the current carriers are positive ions and free electrons. In ionosphere of atmosphere, we get the free electrons and positive charges, and these are the carrier of the electric current. And in semiconductor, the current carrier is holes and free electron. So now let us define current density. It is a very important term. Current density is represented by J, and when current density at any point inside a conductor is defined as a vector whose values is equal to the current per unit area, means current per unit area. This is current and per unit area. Current per unit area of the cross section of the conductor surrounding that point. If you assume this is the point surrounding which we need to find out the amount of current density. What is current density? So first of all, we should find out the current density, that is around this point. The area of this cross sectional area is dA, and the particle or the electrons, number of electrons or the particles are n particles with charge q. Then this is equal to di by dt. So current around this point is equal to di by the area of this cross section with where the particles are n. Then that J gives you the current density. So J is equal to di by dA into n, particle, number of particles, directly proportional. So now if the flow is uniform, so now we know J is equal to di by dA by n, where this is the current and dA is equal to small amount of current in small area of cross section of n particle. So the J is equal to di dA by n, and J is a vector quantity. Its direction is direction is the same as that of E. So this is the direction of the plus charge. The electric field is the same as that of plus charge, and the negative charge flows against this in opposite direction, and the flow of J is to the direction of the E. So its direction is the same as that of E. The SI unit is equal to di by A. I is the ampere, A is the area, meter square. So ampere meter square, A meter to the power minus 2. Dimension is ampere, L minus 2, third bracket you can give in this way. And that for uniform flow of the charge, if it is uniform, then we will write I by A is equal to this. So J is equal to I by A. So now for uniform flow of charge, current density is equal to I by A. A bit earlier we have written I is equal to n into QVA, where V is the velocity of the electron and n is equal to number of particles, Q is equal to charge, A is the area cross section. Now if you put the value of n, I n q v a divided by A, you will get n q into V. So the current density J is equal to n q into V and E. Now what is the relation between current density and electric field? We know J is equal to so the relation between J and electric field density is equal to Z is equal to sigma into E, where sigma is the conductivity. We will define it after Ohm's law, and also you have got in chemistry, electrochemistry, you have got this in second year. So and specific conductivity, you have got the same things. If you have any confusion, I have already done this chapter, you please follow the chapter in chemistry. So J is equal to sigma and conductivity into E. Since conductivity is equal to 1 by resistivity, it is reciprocal to each other, so sigma is equal to 1 by rho. So we write E by sigma, E by rho. So J is equal to sigma E is equal to E by rho. This is the relation between J and E. One of the very important point of the current electricity from this point is very important is the drift velocity, and it is a very important to learn, and you should understand it minutely. It is a bit critical. You just follow. I will make it simple through my discussion. A uniform average average uniform velocity acquired by free electron inside the metal by application of electric field which is responsible for current. The drift velocity is of the order 10 to the power minus 4 mm, very small in comparison to the thermal motion of the free electron. What does it actually mean? Means, say in a conductor, if you just apply potential difference across the two ends of the conductor, a electric field inside the potential is applied across the conductor to end, and field is produced inside the conductor. So potential is applied across the two end of the conductor, and the field is say produced in this direction. So positive charge will flow to the direction of the field applied, field produced inside the conductor, and the flow of the current will be opposite to this one, and we have assumed the length of this conductor is the L, and the drift, whatever defined, where we have defined drift, that drift velocity is assumed here is equal to Vd. Now we'll explain this mathematical part. Now what does it mean? The average uniform velocity means what is drift velocity. Before understanding drift velocity, we should know what is thermal velocity of the electron inside a conductor. So in the conductor which conducts electricity, if it conducts electricity, so it must it is a metallic conductor and it has free electron. Only the ions pair ions there is free electron, and only in the metals there are free electron, or in other cases it is very impossible, near impossible to get free electron, because if you assume the atoms, in atoms there is electron, there is proton, there is binding forces, electrons are not free, and in the molecule again electrons are not free. In the water, on the liquids, water molecules are attracted by some hydrogen bonding, intermolecular hydrogen bonding, so there is no free electron is not easily available, only free electron is available in the free metallic conductor. So when the free electron is there, so what we see that free electron has a natural velocity, natural motion due to the general temperature, normal temperature. At normal temperature it has some kinetic energy. So we know kinetic energy is equal to 3 by 2 kT, and this K is the Boltzmann constant. So kinetic energy is proportional to the temperature T. K is the Boltzmann constant 3 by 2. Then so with this kinetic energy, the electron inside this will starts moves, and this movement of electron with the influence of the temperature is called thermal motion of the electron, and this thermal motion of the electron is much more bigger than that of the drift velocity. Now what's happened? When there is no electric field or potential is applied across the conductor, the electron has a thermal motion. But if electron has a thermal motion, that it should have produced electricity, but no, it will not produce electricity until and unless you applied any potential difference across this one. The reason is that when inside the electron, all the electrons are constantly in zigzag where they are in constant collisions during their motion. So they moves, and with the positive charge inside the metal, there is positive charges are there, they just collide with the positive charge, and this after collision, they before collision and after collision they get some velocity. So their position and velocity changes. So in a net, whenever the electrons are moving in this direction, and after collision with the positive charge, electrons are coming back or dragging back in this direction. So net change of the electron in the inside the conductor, net change, total change is zero due to the collision of the charges. Though they are moving, there is velocity, but the net velocity of electron comes to at zero. Hence no current is seen without the application of the potential difference. So the case is same. If you do not apply any current inside across this conductor, then there will be no drift velocity. If you don't understand for time being, no drift velocity of electron. So drift velocity of electron, after application of the electricity, we get some velocity, drift velocity of electron. So when electric potential difference is not applied across the conductor, the drift velocity is 0 and the thermal motion is also 0. Am I right? They are moving out, but net velocity is the 0, net displacement is 0. So no charge, no current, nothing is there. So both the thermal velocity and the drift velocity is 0 in absence of applied potential difference. Am I right? Now when potential difference is applied, then it has some thermal motion. Am I right? So when you apply a potential difference across this one, so the potential difference will create a field in this direction, and positive charge starts moving in this direction, and negative charge will always move against the direction of the field produced inside this one. So the natural velocity of the electron is get a serious setback due to the drag velocity of the potential difference across, which is potential. After application of potential difference, the field is in this direction, and this field has applied the force, a backward force upon electron, and it is dragged back. That's why the drift velocity is less than to thermal velocity of electron. Earlier we have seen it has automatic velocity, but net velocity, net displacement is 0. But the thermal velocity, drift velocity is much lesser than the thermal velocity, because the electron as a whole in thermal condition, before attaching to the potential difference parameter and before applying potential difference, it has thermal velocity. Now as soon as you have applied a potential difference, this one, the potential difference has created a field towards against the direction of the velocity of the electron. That's why the drift velocity will become less and less than that of the thermal velocity before application of the potential difference. Now what's happened? Due to application of potential difference, the electron will in this way will shift a bit back towards the electric field generated, against the electric field generated, and that velocity of electron is called drift velocity, and this drift velocity is essential or the responsible for the current, and its velocity is much more less than that of this. Now this drift velocity is equal to I is equal to, where that V is the drift velocity. So better you write is d1. So NeAVD, where I am writing, telling you n is the number of the particle, E is the electron, A is the cross sectional area, Vd is the drift velocity. So from this you can write so now we can say I is equal to NeAV. Am I right? We have already derived earlier. In place of U, have written Q. Here we have written E, because N is the particle. So E of electron is equal to total charge will be number of the electron into charge of the electron. A is the area of cross section. Vd is the drift velocity. So I have phased out. Vd is equal to drift velocity. So from this we can write Vd is equal to I by Ne into A. A bit earlier we have proved I by A is equal to current density. So that is equal to J. So J by Ne. Again we have established the relation J is equal to sigma E a bit earlier. So we can write sigma E by Ne, and that is equal to Again sigma is equal to 1 by rho resistivity, so that is E is equal to 1 by rho N E, and again E is equal to L by B, because we have assumed the figure I have drawn. I already had given the length of the conductor is equal to L, that is equal to V by L. So E is equal to V by L. So V rho L N E. So potential V is the potential difference. Am I right? So we have got BD is equal to a lot of drift velocity. So a lot of things are there in drift velocity, but out of this I will just point out 2 or 3 things. That drift velocity is directly proportional to E, number 1. So this will be the last part you just see. Drift velocity is directly proportional to the field produced, electric field produced. So more the electric field, more is the drift velocity, and drift velocity is directly proportional to area of cross section or inversely proportional to the area of cross section. Drift velocity is inversely proportional to the area of cross section of the conductor. If the conductor does not have the uniform area of conduction, say we see in the 3, if it is a conductor, if you want to pass current through this one, so it has area of cross section this and that. It doesn't have uniform area of concentration, area of cross section. So if the area of cross section is in this way, so it will be inversely proportional. More the area of cross section area, less will be the drift velocity, and less the area of cross section, more will be the drift velocity. But if it is if the area of cross sections are the same, then this doesn't have any change in the drift velocity, because say if its diameter is double of this one, but it is uniform, it is also uniform. If area of cross section of A and this is area of cross section of 2, now what will be the change of the drift velocity in these 2 cases? Since the area of cross section is uniform in both the cases, so it doesn't have any change or effect on the drift velocity, since area of cross section all through is same. If its diameter is more or diameter is less than other one, it doesn't have effect upon the drift velocity. This is all about of today's class, and in the next class I will talk about with new point. Thank you for watching the class with utmost patience, and please don't forget to subscribe the class. In the next class I will come up with new other concept. Thanks a lot for watching the class.